Good morning, ladies and gentlemen of Precalculus. Good to have you here today. At the end of class yesterday, do you remember the very last thing we talked about?
Yes. Cosines.
Law of Cosines. And in fifth period, Elizabeth called it, I asked the class, what did we call that? And she said the law of Pythagorean, the Pythagorean theorem adjusted for angles other than 90 degrees is what she called it, which is really a good explanation of what it does. But anyway, we have law of cosines. And what I had you do yesterday, I had you write down this little version of the formula, which is C equals square root of a squared plus b squared minus 2ab cosine c. Do you have that there somewhere on your formula chart? If you don't have it there, I want you to get it there. Do you have a formula chart, Will? Okay. And so what happens is, for this case, what I like to do is I like to use the C formula because for me it helps me with the uniformity every time. So if I have a letter here, I have my known angle is 121, 131, so I want to change that to C. And I want to change the opposite side to little c. And then I'm going to change this one over here to B, and the one opposite here to little b. And then this is going to be, 13 is going to be my little a.
Do you have to change it?
You don't have to change it, but if you don't change it, you have to use like the other version of the formula, like a squared equals b squared plus c squared minus 2 bc cosine a. So if you don't relabel it, you're going to have to change the formula or use a different version of the formula. You want to use a different version of the formula? Okay, I use C. To me, and one reason I do that is I just think I have a fixation with the Pythagorean theorem. I want to keep it close to Pythagorean theorem, which is going to be a C equals. So anyway, what happens is, if you, it's going to be C is equal to the square root of, we have 13 squared plus 8 squared minus 2 times 13 times 8 times cosine 131 degrees. And then you go to your calculator, and I'm going to go to quit, which is this one right here. Yes. So I go here, make sure I'm in degrees. I had people in one person in fifth period had trouble because I pressed the wrong one. Because he had the calculator in radians. Cosine 131. So that's going to be it, right? Then you press enter. So I get 19.221. So we'll see it equals 19.221. So that's going to be little c right over here. And next, now we still have, it says solve, we're looking for every single angle inside, right? So what are we missing still? We're missing two angles, aren't we? Okay, when you have two angles, you're going to use what to solve for the next angle? Pardon me? Law of sines. Yes, very good. So we're going to say B is equal to inverse sine, and what we're going to have is we're going to have this side here, because it was going to be sine, because originally we were going to have sine B over B equals sine C over C. That's supposed to be a b. And so we have, as we cross multiply the b here, and the little b here, the way I've labeled it is 8. So we have 8 sine c, so it's going to be sine 131 degrees over side c, which is 19.221. And so b, angle b, is equal to, go to your calculator, and you put your inverse sine of 8 sine, and I want you to watch what I'm going to do here next. Okay, are you watching what I'm doing next here? Are you watching this? Okay, what it is I wrote down 19.221, but I can put an exact value here by pressing second A and S. And so if you have this is helpful because if you have a calculation that's going to be used in the future, you're just going to go ahead and press this, and you get a more exact answer. Because what it does, it puts this in here for A and S instead of 19.221. So you get 18.307. So 18.307 degrees. So that's going to be angle B. So we have side C, angle B. We need to find angle A. And how do you find angle A? Well, angle A is going to be 180 minus 131 minus 18.307. So angle A is going to be equal to
30.692.
and I'm going to put second A and S. So 30.693 degrees. So here it is, all solved. Now what I want to do for problem 2 is I want to call on somebody from the class to solve problem 2. So everybody, pardon me?
How do you know like which numbers to change to the A and B?
Yeah, what I did,
You don't have to change it.
you don't have to change it. And I think what happens, I think on problem 2, if I'm not mistaken, the given angle is C. Is that right?
Yes.
Yeah. I just do this for my convenience. I know it might confuse somebody. Kaylee says it probably would confuse her. So she can keep the B form here if she wants to. That's fine. Well, and before the end of class, I want to show you how Elizabeth solved that circle equation, because that was really
The first one?
clever. The 8th SAT problem of the day. I'm going to show you how she did that. So here we don't have Kinsey. Kinsey couldn't make it today.
She's at clinicals.
Oh, you told me already. Yeah, she's going to show up here. I feel like I have 2 more things to try to remember today. Yeah, McKinsey is showing up like that, right? Everybody else is here. Angel, you weren't here yesterday, were you?
No.
No, I sent out the video from yesterday's class. Did you see that? For mine, I sent out the video from yesterday's class.
I didn't get a notification.
You didn't get it?
No.
Are you getting the notifications I send out every day?
I've been getting ones before, I think. Just didn't get this one for some reason.
You didn't? One problem I had yesterday was I mistakenly listed that video as unlisted. I published it as unlisted, and Becky said that she got it, but if they don't show a link, the unlisted you should get, because the links should still put you there. Okay. All right. Are you ready for problem 2? Anybody yet? Yes, Will is. Anybody else? Emily's still working on it. You ready? Carmen, you ready? Kayla, you ready? Problem 2?
Okay.
Emma's working on it, looks like.
Just double checking.
Just checking. Good.
Is there a certain equation you use for number 3 and 4?
Yeah, okay. Number 3 and 4, Will's asking a really good question. Is 3 and 4 are law of cosines applications, but it's a situation where you have 3 sides you need to solve for unknown angles, is what it amounts to. So I'm going to show you how to do that, because that's an application that's not going to be as straightforward. Okay, that was a good question.
I'm the one who put in the answer,
Pardon me?
like to the bottom. Like if I push the second.
ANS?
Yeah, it won't let me do it. Every time it pops up as an error.
Well, oh really?
Yeah.
Huh. Well, what it does is it's supposed to take that last number that you
It did it
calculated.
earlier, but it won't do it now.
It won't do it now? Okay, there's something wrong, I don't know what it is. Okay, I'm gonna call somebody here. So we are going to have either Will or Emma. This looks like it's Will. All right, Will.
Okay.
All right, Will.
So you set up the law of cosines equation. I've got the length of C is 11.39.
Okay, let's go ahead and put this. We would have 14 squared plus 12 squared minus 2 times 14 times 12, right?
Yeah. Cosine.
Cosine 42 degrees. So you get 11.39. Did everybody else get that too?
No.
And I'm just going on memory from yesterday's class. I mean from last period's class. I think the answer they got was 9 point something.
Yes.
Yes.
9.503.
Are you in degrees? Calculator in degrees?
I guess I typed it wrong.
Or are you typing it wrong? Now here's another thing that Becky came up with in 5th period. And in 5th period, the same thing happened where somebody who gave the answer had some 20 something. And one thing that Becky noticed was that if you look at the numbers, they can give you a fairly good idea of what a reasonable answer is. And so, would the answer to this be 20 something here? No, because it's probably going to be less than either of these.
The angle of B would be 57.7.
So what'd you get for this one? 9.503?
Yeah.
And so you got angle B, so B is equal to inverse sine of 12 sine 42 degrees over 9.503, right? And that's going to be, what'd you say it was?
57.7.
7.7. 57.7.
It's 6666666.
Oh, okay,
That's why he said 7.
all right. So we'll say 667.
It's not, it's 51, not 15.
51, not 15? Yeah, it doesn't make sense.
51, I thought 57.
Yeah, I got 57.
57 point something?
Yeah, it's 57.667.
Okay. So that's that. So that's angle B. We got side C, angle B, and what's angle A?
Angle A is 80.334.
80.334.
Yep.
Degrees, okay? So that's solved now, okay? Good. And this brings us to problems 3 and 4, which also the law of cosines can solve for. Now, I want you to stick with me for 3 and 4. And here's what happens for 3. What you have is a side application. So what I like to do for these is to solve for the biggest angle first, if I can. And for law of cosines. And what you're going to do is, if you have the biggest one is going to be this angle here. So I can change this to C if I want to. So I'm going to change this to C, and this will be little c, and this will be big A, and this will be little a. So what I'm going to do is I'm going to say 27 squared, or C squared, I'm just going to write it out first. C squared equals A squared plus B squared minus 2AB cosine C. And then I'm going to write out what the numbers are. So 27 equals 24 squared plus 19 squared minus 2 times 27 times 19 times cosine C. And so we have this cosine C buried over
How
here.
did you get 27?
That should be 24, sorry. Yeah, thanks for catching that. I'm kind of in a hurry. Okay, good. And so we're trying to find this, right? What I want to show you, what we're going to do is we're going to solve this equation here for C. And when I solve this equation for C,
Don't you have to put the square root?
what I want you to do is I want you to write down the formula once we solve for this angle over here. So I'm going to just write this down as A squared plus B squared minus 2AB cosine angle C is equal to C squared. Okay, how do we solve for angle C? Okay, the first thing we do is we're going to subtract A squared and subtract B squared from both sides of this equation.
Well, isn't there the square root on it?
There's no square root. Okay, there's no square root in this equation. Now there's a square root. Yeah, there's a square root. The one I gave you after you solve for C will have a square root, right? But in the original equation, there's no square root on it, right? Okay, good. And so we subtracted A squared and B squared from both sides, And so that cancels out this over here, right? This is canceled. And what's the next thing to do? Divide by negative 2ab. So now we have all this divided by negative 2ab. And so now we have this canceled out. What's left? Cosine c. So how do you solve for c? C is equal to inverse cosine of all this. So what I want you to do on your ACP formula chart is I want you to write down this version of the formula here, if it's legible. Is it legible? Let me just clean it up a little bit here. That's c squared cosine. Can you write down the formula there in your formula chart someplace? Is there room? There is, right? And this is going to be the equation you want to, version of the equation you want to use if you have a side, need to solve for unknown angle. And so in this case, we have C, angle C is going to be equal to c squared, 27 squared, minus 24 squared, minus 19 squared. I forgot something, but I can fix it. Okay, over negative 2 times 19 times 24. But I forgot to do this. It's going to be inverse cosine of all this. So angle C is equal to inverse cosine of all this here.
I calculated, won't let me do second sign.
Oh, here we see.
Just says thing. Well, I'm doing it. It just says thing.
One thing you got, did you use the right sign here?
Yeah, I use the negative. Yeah, use this one.
Use that. And then use that one. Use that one for this little down here, right? Bad operating system we have. Maybe I have to reinstall an operating system, see how that works. Okay, it looks good so far. Minus 10 squared, minus 24 squared. Over 2 times.
You put negatives right there?
Okay.
You never put lines.
The ones on top are negative here, the one on the bottom here is that way. Yeah, so you use that one. Yeah. And Emma, what'd you get for that?
76.817.
817 degrees. So there's angle C. And angle A is going to be equal to 24, our inverse sine of of 24 sine 76.817 over, what was the side opposite, 27, right? So that's what A should be here. So what is angle A?
59.936.
936. And that's degrees. And one thing you can do is you can use law of sines for the other one and check by adding up to 180. But I just assume I'm right. We can just subtract. We have angle B is going to be equal 180 minus these two things here, minus 59.936 minus 76.817. And so that's going to be what?
43.247.
0.247 degrees. And actually, you can use law of cosines to solve for every one of these angles, if you wanted to, right?
Yeah.
You can just switch things around. And we're just about out of class time. I want to show you, before we go, I do want to show you